So the basic idea is, again, we need to combine the like terms, okay? And for that, as you can see, we have combined the terms with without I, and we have combined the terms with I's, right? And if I can add this now, just simple algebra, and I can see this will be 3 minus 2, so 1, and 5 plus 3, 8. And again, you can see it's definitely of the form a plus ib, so it's a complex number. Any question from this? Anyone? And that's the idea is same for the subtraction as well, because as you can see, we have actually gone for a type of subtraction here, right? So again, idea is the same for subtraction. Let's see one example of subtraction, and hopefully it will make more sense. So let's take 6 plus 4i minus 3 plus 6i, okay? And again, we'll combine the like terms. So we'll combine the terms without I, which is 6 and 3. It will be 6 minus 3, okay? And we'll combine the terms with I, right? Let's do that. With I, we have 4 and 6. It will be 4 minus 6, okay? So clearly, it will be 3 plus minus 2 of I, or 3 minus 2i. So that's your answer. And again, that's still a complex number. Any question from this? Simple algebra, as you can see, you just need to combine the terms with i's and the terms without i's. Okay. All right. Next, we want to see how can you multiply two complex numbers. Okay. So for multiplying, again, we'll use the same idea as real numbers. That means we'll multiply each term with the other. Okay. We'll multiply the terms with each other. So if I have a problem like this, let's say 5 plus 3i times 2 plus 7i, we have two complex numbers, right? These are two distinct complex numbers. So if it was a real number, we would have multiplied each terms with the other one, right? Like this. And the idea will remain the same here as well. Let me erase this. Okay, so first of all, it will be 5 times 2. Okay, so 10. It will be 5 times 7i. So clearly it will be 35i, right? Then again, same goes for the other term. It will be 3i times 2. So 6i, right? And the last one is, of course, 3i times 7i. So it will be 21i squared. Okay, now here is the new thing. We know I is square root of -1. So what's I squared? -1. Very good. If you square it, you can see the square root sign will get vanished. We'll have a -1. So that means it will be 10 plus, if I combine these two, it will be 41i, sorry, 41i, and this guy now will be 21 times -1. So if I write -21, do you guys agree? Do you agree with that? Okay, very good. Because I squared is -1, right? So 21 times -1 always gives you -21. And you can simplify it more. +10 and -21 will give you a -11 plus 41i. So that's your product. This is the product of these two complex numbers. As you can see, apart from this guy, everything else remains the same for the complex number. The idea for the complex number is exactly the same as we have for the real numbers. But the only thing you need to take care is the I. Wherever we see this I and I squared, we need to keep an eye on that. Okay? Any question from this? No question at all? All right. Next, as you can assume, next we want to see what happens if we divide two complex numbers. Okay, we want to now divide two complex numbers. But before that, we want to know one more definition, one more item, which we say the conjugate. And you have heard this word in Math 95 as well. Okay, you have heard this word. So the conjugate for a complex number is basically the same thing, only the sign in front of I will get changed. That means mathematically, if I want to express it, if a plus ib is a complex number, the conjugate of this, we actually use a bar over this. This bar means the conjugate of this. That means if I write z and if I give a bar over that, this means we are trying to find the conjugate of z. Okay, so it's really important to use this bar. Okay, so the conjugate of this will be actually the same thing as I said, just the sign in front of I will get changed. There you go. And it will be true for every conjugates. Okay, whatever your complex number is, just change the sign in front of I. If it's minus, make it plus. If it's plus, make it negative. Make it minus. That's it. You don't need to worry about the sign here. Okay, you don't need to worry about the sign in front of the term which doesn't have I. Okay, you just need to change or alter the sign in front of I. Okay, so before we go for the division, let us see how does a conjugate work, or how can we calculate a conjugate. Okay, so let's say we have a z and the conjugate, the complex number is 3 plus 4i. So what should be z bar? What should be the conjugate of that? Anyone? 3 minus 4i. Very good. So it will be 3 minus 4i, right? Now, it's really important to find the conjugate, and we want to see what happens if we multiply a particular complex number by its conjugate, because we'll actually use this concept for the division part. Okay, So let's see what happens if we multiply a complex number by its conjugate. So 3 plus 4y times 3 minus 4y. Again, you have seen how can you multiply two complex numbers, and you can use the same procedure here, right? You can, whatever you have done here, that means multiplying each term with the other and then simplifying it further will give you the result. But you can also use another formula. Can you eyeball it? Anyone? Can you see which other formula we can use here? Just give it a try. How can you write 3 minus 4i squared? Which formula is that? So the formula is, as you can see, a plus b, a minus b. Now can you relate? Difference of the squares, very good. So we can actually use this formula instead, right? You don't need to. If you can successfully do this, you will still get the same result, but again, it will save your time, right? And as a mathematician, we want to use it more efficiently. So it will be 3 squared minus 4i squared, right? It will be 9 minus, sorry, not 4, it should be 4 squared, so that means it's 16, and I squared is negative, so 9 plus 16 will give you 25. Okay, so the idea of using the conjugate is to get rid of the complex number. Okay, so if you multiply one number by its conjugate, in response to that, as a result of that, you will actually get a real number. You can always rewrite it as a complex number, but again, we can actually get rid of the I. Okay, and the simple reason is this formula, this squared, uh, helps us to get rid of that I, because I squared will give me a negative 1, right? So we can get rid of that I. So the idea of using the conjugate is to get rid of that I. So in other words, if I want to rephrase it, if you are given, let's say let's say I have given you a complex number. So if you are given a complex number, how can you get rid of I? How can you get rid of the imaginary part, I? And the answer is multiply that by the conjugate. Okay? And we'll use this idea for division. Let's see that. Okay, so oops, sorry. Okay, I can use Z, no problems, because generally we use Z for complex numbers. So that's not a problem. Anyway, so let's say we have Z equals 3 plus 4y, okay? And we want to write 1 over Z, okay, as a complex number. That means in the form of a complex number. Clearly, 1 over Z will be 1 over 3 plus 4i. Is that in the form of complex number? The answer is no, because we know the form of complex number is a plus ib or pi. It's definitely not in that format. We have a numerator, we have a denominator. It's not in that format, right? Okay, so what should we do? So we will actually use the conjugate of this, that means z. And so 1 plus 3, 1 over 3 plus 4i. What's the conjugate of 3 plus 4i? It's 3 minus 4i, right? Very good. 3 minus 4i. And as you are, excuse me, as you are keeping the value intact, if you multiply a term by something, you need to divide by the same thing, right? We have seen this before. We have done this for real numbers as well. Because you are keeping this value intact, you can't really simply multiply by something. If you multiply by something, you need to divide by that same thing as well to make the balance, to keep it same, to keep the value intact, right? All right. So 3 minus 4i will be in the numerator. No problems with that. But in the denominator, now we can use the same formula. And I think we have it already, right? Yeah, for 3 minus 4i times 3 plus 4i, we'll get a 25. So instead of this, we can write a 25. Do you agree? I'm not showing this because I've just showed it 2 minutes back. You can see 3 plus 4i times 3 minus 4i will give me 25. I'm just replacing that here. Okay. Do you guys agree with me? Now, as you can see, there is no I in the denominator, which I wanted. So now I can actually subdivide this numerator like this. 3 over 25, okay, minus 4 over 25 I. I can subdivide, right? 3 over 25 and 4 over 25. And now, as you can see, it's definitely in the form of a plus ib, right? That's your a, that's your b, along with the negative though. Yeah. So that's definitely a complex number. And that's what we wanted. Any question from this? So you need to see the question very carefully. Okay, if the question says write in the standard form, that means you have to write in the form a plus ib or a plus bi, whatever. You need to write in that format. Okay, that's the standard form. You can't really keep it like this. You'll get penalized. Some points will be deducted. Whenever, even in the offline class, when you meet the professor face to face, still he will deduct some points because that's not the standard form. The standard format is a plus ib. All right. Okay. So what else? Okay, so a couple of really funny and interesting properties. The conjugate of the conjugate of z is actually g itself. Okay, that means, and you can actually verify it. So 3 plus 4i, the conjugate of it is 3 minus 4i, right? Now, if you take the conjugate of that, 3 minus 4i, it will become 3 plus 4i, exactly same thing. Can you see that? That means if you take the conjugate of a number, you'll actually get the same number in return. That's one interesting property you can remember. Okay. The next thing is the conjugate of the sum of two complex numbers equals the sum of their conjugates. That means if you have, let's say, W, this is literally the same thing as this. That means if you have the conjugate of Z and W, you can add those two and you'll actually get the same as this. Okay, and if you want, I can show one example of that as well. Let's say Z is 3 plus 4i and W is, let's say, 4 minus 6i. So Z plus W will give me 7 minus 2i, and the conjugate of this will be 7 plus 2i, right? Let's see what happens if we do this separately. So Z is this, so Z prime will be 3 minus 4i, and W prime will be 4 plus 6i. So now if we add these two, as you can see, 3 plus 4, 7, and we have a plus 2i. So as you can see, it will give you the same result, even if you do it all together or separately. Okay, so that's a good property as well. And same goes for the product. So if you multiply two different complex numbers, the conjugate of the complex numbers, or if you multiply two complex numbers and then find out the conjugate, you'll actually get the same result. Okay, just like the one we've done for the sum. Okay, any question up to this? No question at all? Okay, so let's take a break for a minute or two and let's refresh our mind, okay? So if you have any concerns about tomorrow's quiz or test on Friday, or even for the homework, which will be due on Thursday, 11:59, you won't really need that much time, because you will see once you start, there is only one question probably in one of the assignments and 2 or 3 in the other. So the number of questions in those homeworks are really a few. So you shouldn't need too much time on that. When we review, will we go over questions similar to the 5 questions on the test? Well, definitely we'll practice problems quite similar to the topics. You know, obviously it will be the same. Well, it may not be of the same length because I combined 2-3 problems together. Because as you can see, only 5 questions, and you'll be given 2 hours. It will be of 50 points. So I've actually combined 2-3 questions together. So, well, as I said, you'll have several parts, probably 5-6 parts for each question. You'll have different scoring opportunities as well. Okay. One question is short, although I guess one of the questions has only 2 parts, finding the domain and all that. Okay. I will get K and still don't. Okay. Okay, I'll come back to you. So about the test, the one you have solved for the homework, the one you have seen in the quiz, the question will be the same. As I said, I combined 2-3 questions together. Okay, so that doesn't really make the question harder, but just a little bit longer. And you can clearly imagine why. There will be only 5 questions. And when I solve it, it took me 29 minutes. So you should be able to do it in 2 hours, no matter what. So uh, in the review session, we'll definitely cover each type of questions, even each part of question, but maybe not exactly the way you can see that in the exam. Because in the test, in the review materials, the questions may or may not be that long. We'll see uh, once we start reviewing stuffs tomorrow. Um, one more thing, you have a review session. I did get an email. Uh, I was going to make an announcement. I'll do that, of course. I'll send you the email. Math Center is going to hold a review session for you. So before the final, you can also chat with them and take their help, because it's a good way to uh, check your work, and it's never bad, to take help from others, because it's on offer. Why not take those help? So it's a good practice. And about that question from the homework, let me go back there. So this is how I calculated K. Let's please repeat the question, because I did it in a right but still incorrect. Which one, Daniel? Is it the same one as you can see on the screen? Excuse me. So for finding a population, uh, as you have this model, right? Obviously, your N naught is given, right? Your initial population is given. Your timeline is given. So what is missing? You first need to identify that. You can't memorize a particular method and just try to implement that in the exam. You need to understand what the formula means and how does each notation contributes to that. Okay, contributes to that. So if your initial population N naught is given, the timeline, which is 22 years or 24 months, that's also given. That means if you want to know the population uh, uh, at t equals 24 or after 24 months, you also need this value of k. Do you agree? And if you want to solve it, you need to use the clue that will also be given. You need to use that clue. So what's the clue that's given here? So the clue says the population will get double in 10 months. So that's really important as well, because it says 10 months, not years. Okay, it says 10 months. That means you're expressing your t in months, not years. So you're plugging in 10 here, and you also know the population will be just 2 times than the original one. So the original one is N naught, twice that will be 2 N naught, right? And you can now use the population model to solve it for K. And we have replaced T by 10. N naught and N naught from each side will nullify each other, will get cancelled. And then using this very property, we can solve it for K. Does this make sense now? If you see 1 or 2 problems from the book, or at least from the file of the resource, uh, that should be helpful. Okay, so what's the time for your population T? for part B, of course. I mean this part. What's the value of t? Why it's 4 years? How did he get 4 years there? Oh well, as I said, 2 years, 4 years, 3 years, it will be different for each person, because uh, the numbers are actually changed for each one. Okay, so that's not a problem. If if I say 2 years, then it's 24 months. If you have 4 years, you can clearly understand what your t should be. I was working with 2 years, not 4 years. That's why it's 24. Now, does it make sense? It will be different for each of you. Okay, it will not be the same. For somebody, it could be 3, it could be 5, but you need to express it in terms of months. So for 2 years, in terms of month, I can write 24, right? So you need to just convert your years in terms of months. That's it. As I said, that's the idea. The numbers will be different. All right. Any other questions? Okay. So I think we can see 1 or 2 problems. How can we solve? Where is that? Okay, here you go. So now we want to solve equations which might involve the imaginary part. Okay, unlike to the problems we have seen for the real numbers. Okay, so let's try this. If you have x squared equals 9, you want to solve it for x, right? How can you do that? If it was x squared equals positive 9, you straight away you could have written x equals plus minus square root of 9. That means plus minus 3, right? What should you do for the complex number? So the idea again remains the same, okay? So it will be plus minus square root of negative 9. Oops, sorry, that should be x, okay? And now what we can do is it will be plus minus negative 1 times 9, right? You don't need to rewrite it though. I'm doing it for the first time. That's why I'm showing this. You don't need to write this step. So for this negative 1, you can write like this. You can separate this. And for this negative 1, you can write I. And square root of 9 is 3. Or in other words, you can write a 3i. Okay, so that should be your answer. Can you see the difference? As I said, the idea is the same, but for the negative, you need to include the imaginary part, that is I. Okay? Any question from this? Okay, one more problem before we move to 1.4. So if you have a problem like this, x squared minus 4x plus 8 equals 0, that means it's definitely in the form of ax squared plus bx plus c equals 0, right? So for this format, we know the formula is x equals negative b plus minus b square minus 4ac, square root of b square minus 4ac over 2a. That's the formula, right? Only when it's a quadratic equation. That means the degree is 2. Okay. All right. You can also just factor, right? Well, it depends. You can't really factor for each and every problem. You can't factorize for each problem. For this one, you might, probably you can, but as I said, it depends. Not every quadratic equation could be factorized. Not equation, I should say expression. Not every equation could be factorized. It could be in the least format. You know, maybe it could be a possibility that you can't really factorize it anymore. So, but you can definitely use this formula whenever you have a quadratic equation. That's for sure. You don't need to check anything. You don't need to spend time on factorizing. So one good idea is to use this formula. Okay. All right. Next, if you remember, we did work with determinants, which is this guy inside. Let me use a different color. B squared minus 4ac. That's the determinant, right? And if you remember, we did say that if it's negative, strictly negative, then we say we have a complex solution. That means our solution will be a complex number. Okay, or I would say the solutions, because you'll have two solutions because of this. The degree determines how many solutions will be there. So if it's negative, the determinant, if it's strictly negative, then you'll have two complex numbers. Okay, and let's see what happens. So for this problem, our x will be, first of all, you can check whether it's a complex number or not. Let's do that. So for this problem, our b squared minus 4ac is, b is negative 4, a is 1, c is 8. So 16 minus 32, negative 16, which is less than 0. So definitely it is going to give us a complex number, right? The solution will be complex numbers. So let's try that. X will be negative b plus minus square root of b squared minus 4ac over 2a. We know b is negative 4, so it will be positive 4. B squared minus 4ac is negative 16. Negative 16. A is 1, so it will be 2. And we can rewrite that square root as 4i, right? Because square root of 16 will be 4, and because of this negative, we need to add this I with our expression. Not, I shouldn't use the word add, we need to write the I with this, okay? Does this make sense? As you can see, the square root of 16 is 4, and because of that negative, it's going to be I, right? So we can simplify it further. We can factor out 4, and we can write like this, okay? Oops, yeah. So this could be written as 2 times I, oops, sorry, 1 plus minus I. So one solution could be 2, 1 plus I, that means 2I, or rather 2 plus 2I, or you can keep it like this, no problems. And the other one will be 2, 1 minus I, or 2 minus 2I. If you want, you can keep it like this. Okay, so these are the solutions for this problem. What is that? Sorry. Oops. There you go. For this problem, the solution will be this. These two. Any question from this? As you can see, once again, the idea remains the same, what we have done for the real number. But again, the only additional factor here is the imaginary part, which is I. Okay. So that's it from the appendix. We'll now briefly go over section 1.4. That's a smallish chapter. In this section, we want to know the ins and outs of a circle. It doesn't look like a circle though. Let me redraw it. Now it does look like a circle. Okay, so for a circle, you always have a center with respect to which your circle is drawn, or your circle is generated, whichever, however you can define it. And you can actually find the distance from the center to the perimeter, right? I shouldn't say the perimeter, it should be the boundary. Anyway, the outer boundary, yeah. So this entire length is the perimeter. Sorry. And we say the distance from the center to the outer boundary is called as radius. Okay, this distance. And for a circle, whichever direction you choose, this length will be same. Okay, if you draw a circle, the distance from the center to the outer boundary, or wherever you draw a line to the perimeter, joining the perimeter, the length will always be the same. So radius for a certain circle is constant. Okay, it's a fixed value for each circle. Okay, so for a circle, oops, sorry, if it's centered here, the length, I mean the radius, is denoted by R. Okay, shouldn't be here, it shouldn't cross that, it should just touch this line. Yeah, okay, so your radius is going to be R. And if your radius is R, let me write it for you. Radius is R. Oops. Your perimeter, let's say P, is 2 pi R. That means the entire length of this, let me use a different color. I'm using a blue. The entire length of this blue line is 2 pi R. That's the perimeter. And the area, that means the entire region in the green, the area of that circle is going to be, sorry, pi R squared. Okay, these are the formulas for a circle. All right, what else? We need to know how can you draw a circle, or if a circle is given, can you eyeball the radius or any other properties? Okay, all right, so one ideal equation of circle is this: x minus a, the quantity squared, plus y minus b, the quantity squared, equals r squared. A circle satisfies this equation, or a circle follows this equation, okay, where AB is the center of the circle and R is, of course, the radius. So that means if the center and the radius is given using this formula, you can always get the equation of that circle, and you can always draw it in a graph paper, right? Now, how does it work? So let's say, I'll actually show both ways. One equation will be given. You can derive the center and radius, and the other way also. So let's say a circle is centered at 2, -3, and the radius is, let's say, 5 units. Okay, let's say 5 centimeters. What's the equation of this circle? So it will be x minus 2, the quantity squared, because as you can see, this minus is actually in the formula. Okay, it's a positive 2, so x minus 2. Okay, and y, you have a minus in the formula, a minus with the 3, it will be y plus 3, the quantity squared. And the radius is 5, so it will be 5 squared. This should be your equation for the circle. Is there any question? How did I get this? Take your time. Just try to see what I've done here. Just if you know this formula, you can use this formula to get the equation of the circle. Okay? Are you guys with me? All right. So, what happens if we want to go in the other direction, the opposite direction? So let's say this is given, x plus 5, y minus 1 equals, let's say, 9, okay? This is given. We want to know what's the radius and where it's centered, okay? Can you do it for me? Anyone? Just give it a try. Just compare the formula you have seen and the problem I've just showed. Just give it a try. No, radius is wrong. Radius is not right. Radius is 3, very good. Because you can see radius is r, where the equation is r squared, right? Yeah, very good. So yeah, it's centered in -5, 1, and the radius is 3. Very good. So that's how you can use the properties of a circle. Okay, what else? The next thing we want to know is how can we graph it? Okay, so let's say we have this axis, x and y's. Okay, okay. So let's take this very example. So our circle is centered at -5, 1. So -5, 1, 1, 2, 3, 4, 5. -5, 1 should be here, right? It's centered here, and the radius is 3. So whichever direction you go from here by 3 units, you should be doing all right. So the idea is just take 3 units from here. So that's 1, 2, 3. That's 3 units, right? And just draw a circle from there. Okay, because it's 3 units either way, either direction from the center. That's the definition of a radius, right? Wherever you go from here to the perimeter, you'll always get 3. So the idea is start from the center. In any direction, go up to 3 units. Go or cover 3 units because the radius is 3. In any direction, doesn't matter. I have gone in the upward direction. You can go to your right or left or to the down side, doesn't matter. Just go 3 units and draw a circle maintaining that. Okay, you have the compass. You can draw it using that. Okay, just make sure that from the center your circle is maintaining the distance of 3 units. Okay. All right. Any question from this? All right. Next, the other ideal equation for a circle. Now, how does that look like? So, excuse me. So the other equation, the other ideal format looks like this: x squared plus y squared plus ax plus by plus c equals 0. Okay, this is another equation for a square, and for this you can actually transform it into your known format. Oops, sorry, it should be negative. You can actually transform it in your known format. I shouldn't use a here. I should use something else. Let's say m. Okay, and n and r here. You can actually transform this in this format, and of course from that you can get the center and the radius. Okay, let's see one example of that, and hopefully this will make sense to you. Okay, so let's say our problem is x squared minus 6x plus y squared plus 4y plus 4. Okay, now we want to make this or convert this into this format, right? We want to convert this into this format. Okay, what should we do? Okay, now this is already x squared, no problem. We know the formula is, let me use a and b here. A plus b, the quantity squared is a squared plus 2ab plus b squared, right? Excuse me. So it's already in this format, no doubts on that. Next, we need 2 times x times b, right? So 2 times x, we have a 6x here. We are completing the square. Can you see that? We have actually seen this before. I don't remember which section it was precisely, but we have seen how can we complete the square. We are actually doing the same thing here, okay? This is nothing new. So we have 6x here, so I'll write a 3 because combinedly this will make 6x, right? So clearly this will be my b, right? This is my a, I know that. So my b will be 3. So I need to have a 3 squared here. Okay, I'm using a different color. Soon you will see why. Okay, so this part is done. Next, y is already there, no problems with that. 2 times y times 2, excuse me, because I have a 4y here. So for the formation, I need a 2. So I need to have a 2 here as well, which will combinedly make this 4y. So clearly, it will be a 2 squared, right? To complete the square, okay? And fortunately, we have a 4 here, but we may or may not have it every time. So I'll actually assume that's not here. So what are the things we have added more to this equation or other expression? I should say equation. I think I'd write like this. Yeah. What are the things we have added to this left-hand side, which was not really there? Can you see that? So x squared was there, 6x was there. As I said, I'm using a different color for this purpose. I've added this 3 squared, right? It was not there. I've added this 2 squared, right? It was not there. Okay, so I need to subtract it as well. So 3 squared is 9, 2 squared is 4, and I had that constant as well. The reason I'm showing it differently, although I had a 4, is in most cases, this number will be different, okay? So that you don't get confused, I'm trying to generalize things for you. So just add those values which you need, subtract that as well, and then look at the constant. In this way, you can actually avoid mistakes. And of course, on the right-hand side, we had 0. Okay, so now let me erase some of this. Okay, now this is definitely a complete square. So it will be x minus 3, the quantity squared. Same goes for this one. It will be y, sorry, y plus 2. I'm not understanding that part. Which one? I'm just completing the square. You have seen this before. It's nothing new. Just follow that. Okay, so you have added this 3 squared, right? It was not there. So if you want to keep the value intact, you need to subtract it as well. You just can't simply add anything to the equation. Same goes for this 4. You are adding this 4. So you are subtracting this 4 to keep the balance. And this 4 was already given in the equation. This is the 4. Okay. I'm doing this separately. I could have straight away used this 4 here, but I'm doing this separately because this number could be different. What about if it was 5 instead of 4? Then you would have used a 2 squared here. You would have subtracted 4 and you have written a 5. You would have written a 5 here, right? Can you see what I'm doing here? All right. So this negative 4 and positive 4 will cancel each other. And this negative 9, if I change sides, it will be positive 9. Okay. And now I can rewrite that as y plus 2, 3 squared. You can see, although it was not in the format we are looking for, we can actually convert it to the form we know, to the familiar format. And from this, we can clearly find out the center, which is 3, negative 2, and the radius is 3. Any question from this? Excuse me. Anyone, any question? All right. So that's it from 1.4. And that's officially the last lecture for this semester.